Welcome everyone, good afternoon and good morning to those of you on the West Coast. My name's Paul Coates, I'm Southeast Regional Manager of the American Wood Council. My co-presenter is Ricky McLean, you'll hear from him a little later. The name of the presentation is before you, Choosing Construction Type Just Got Easier, Design Tools to Simplify IBC Chapter 5. IBC, of course, the International Building Code. And we have a course description that you've read or you wouldn't be here. But this is all about determining what construction type a building can be, especially if it could be a wood construction type based on its size and area. So we're going to walk through some things in Chapter 5. We're going to learn to recognize construction types in the tables and so forth so that we can use them more quickly. We're going to look at the code conforming wood design document that we have produced with ICC, which is the first tool that we'll discuss today about determining construction type based on building size in a quick and easy manner. The third objective, we'll go through the new calculator that is an application for your Android or your iPhone to make a quick estimate about allowable construction type. Ricky will go through that. And we're gonna, along the way, address some other topics in the code, including special occupancy provisions in Chapter 5, Section 510 specifically. And then also, we're gonna touch on construction fire safety a little bit. Here's the first poll question. So please let us know who you are. Suzanne, I'll give it back over to you for instructions.
That's great, thank you. Please answer in the box on the screen. I'll give you just a couple of seconds since this is an easy one. What is your profession? Okay. And we are 61% engineers, 25% code officials, and the rest are others and architects. So welcome to everybody who's here. We're glad you joined us, and we hope you find the presentation today interesting and useful.
Yes, glad you're here. Thank you. Here's the outline again. I'll take the introduction part and the background on IBC requirements. Ricky will take the rest. So let's get started on a little review here of the International Building Code itself. It may not be reviewed to some of you because the tables in Chapter 5 are new in the 2015 IBC. We will get the same result. So, but the formulas are a little different. The tables are a little different. They were reformatted in the 2015 in order to provide for fewer mistakes. Doesn't necessarily mean it's easier to do, but the ICC Building Code Action Committee came up with this procedure, which should eliminate some mistakes. There's three primary tables. This is the first one, building height in feet above grade in the main boxes here. You'll notice these are going to be truncated tables. I took out types 1 and 2 construction, which are normally over here. You do enter the table through the occupancy group. And NS stands for non-sprinklered, S stands for sprinklered. You get down here into group R, you have another alternative here, S13R. That means the building is sprinklered with an NFPA 13R standard sprinkler system. It's a little different than the 13 system, the full 13 system. The 13R, many of you are already aware, allows certain spaces in the building, such as certain concealed spaces, to be unsprinkler protected. Therefore, the increases for those are sometimes you don't get the increases, so there's a separate row in the table. Here's another height table, 504.4. Again, you enter with the occupancies on the left. Truncated table with only type 3, 4, 5 showing. Here we have, again, non-sprinklered, sprinklered, 13R down here. This is height in stories. So separate tables, height in feet above grade in 504.3, height in stories above grade, 504.4. And then what about allowable area? This is the third and final table of the main ones in Chapter 5, 506.2, it's actually called, it yields an allowable area factor. So we'll enter this table again with the occupancy group. We have the main combustible construction types here. These rows are a little different. This has NS for non-sprinklered. S1 means sprinklered one-story building, single story, and SM means sprinklered multi-story building. Here's how it looks. Actually, in the code book, you can see in the full table, you got types 1 and 2 construction over here, and 3, 4, and 5 over here, and you've seen this before. Just as we have 3 main tables, we have 3 main equations. First one, very simple, single occupancy, one-story building. Here it is. So here's your allowable area for the single story. The tabular building area factor from that table we just looked at. And then we also pull from that table the non-sprinklered value and take that times the frontage increase factor, add it to the building area factor from table 506.2. How about multi-story? Same equation right here. Same equation, but we've added another factor, and that's for the number of stories. So as you go up higher, of course, your area is going to be reduced because the total building area is limited, as well as the area per floor. Again, most of you are familiar with these equations. The frontage increase factor here, I sub F. The F stands for that portion, or the total of the portion of the perimeter that faces 20 feet of open space, at least 20 feet of open space over the entire perimeter of the building, minus this constant factor. The W is the measurement from the face of the building to the lot line. This can be a weighted average value as shown by this equation. This is equation 5.4 in the code book. You see the measurement of W down here. So you can actually add up the lengths of the perimeter of the building that face a certain width of open space and get a weighted average W to use in your equation. Let me just go back up here for a moment. If you're facing a public way here, you get to use the whole width of the public way for that W. All right, the code, of course, addresses mixed occupancy buildings. So far, we've just looked at the formulas for single occupancy. In the calculator that Ricky's going to go through, this is well explained later on. It does involve, of course, as you know, adding ratios of actual area to allowable area for individual occupancies on a story. And then there's also an additional calculation needed for multi-story buildings. Please note, as we're talking about building size, the basement of a building does not need to be considered to contribute to the allowable area of the building, as long as it doesn't exceed the area permitted for a single story building of that occupancy and construction type. There are a couple different approaches for mixed occupancies. I'm just going to remind us of the basic principle in the code that if you have 2 occupancies or 3 occupancies, you look at the more restrictive one, and if the entire building can fit into the parameters, the limits of area and height for the most restrictive, you're good to go. Design it, its size based on that most restrictive occupancy. No other particular fire resistance separations required. 508.4, however, if you can't fit into the non-separated, you can put a fire resistance rated separation between the occupancies in accordance with Chapter 5, that section 508.4. Do your sum of the ratios exercise to make sure it works. Ricky will touch on that a little more clearly. And then also, of course, you got the multi-story calculation, which is the same kind of deal. Hey, let's try another poll question, see if I've lost anybody yet. Suzanne?
Okay, under what conditions do basements contribute to allowable building size? if not protected with sprinklers, if exits are through the story above, if it exceeds the allowable for a single-story building, or all of the above. Going to give you about 3 more seconds. Okay, and I'm going to close the poll here and share the results. And the majority of people said C, if exceeds the allowable for a single-story building. And Paul?
Well, that's great. That is the correct answer. The others sounded plausible. Might be a concern in some other provisions of the code, but not for this one. This is the only restriction in terms of considering the basement as an allowable or as part of the size of the building for area. All right, this has become a really good tool for designers and code officials. It's become very popular. We published this document along with the International Code Council. Their logo is down there on it. It serves as an index to the IBC. These are commercial building, anything other than single or two-family dwelling or townhouses. The commercial provisions for wood in the building code. And one of the great features of this, which covers only these occupancies, by the way, but one of the great features is it's got a set of tables in the back by which, and here's the first tool for today, you can access this document, CCWD, in a PDF form on your phone even, or on your computer, or in the glossy pamphlet that we love to hand out. And you can do a quick estimate of building size. I'll show you how quick. Here's an example, 1-story, type 5B business building, very simple. 13 sprinklers, 13 system sprinklers provided, 15-foot height. You can see the perimeters there. Take a look. If you have the code conforming wood design document and you flip to the back pages, you'll find these tables back there in order by occupancy and by whether they're sprinklered or not. So there's a similar table to this one for non-sprinklered. This one is sprinklered. In our example, we had a single story. As you recall from the floor plan or the site plan, we had 50% open frontage, at least facing it. 50% of the perimeter faced open space of at least 20 feet. You can see immediately, without doing any calculations, just draw it right from the table. That's our allowable area per story. We're okay. So, same example, nothing's changed here. What if it's unsprinklered? Unsprinklered, now we're in table 3 in the CCWD. Again, 1 story, again, 50% open frontage. You get 11,250 square feet per story. This one's no good. See how that works? This is one of the best features of the code conforming wood design. If we were to do this same simple example right out of the code book, it's not too bad, but here's the calculations. We get into that. We draw these values from the tables. We do the calculations. We come up with the same thing. This does give you just more or less an estimate because the tables are simple to use. We had to limit some things. You get an estimate. You don't get to use the weighted W, for instance. You won't get a completely exact number, so you will have to check it to the code book. That'd go for anything. You'd always want to check it later on before you make your final decisions directly to the equations in the code. So I'm going to turn it over to Ricky now to go introduce us to the calculator. And we will have a question and answer session at the end sometime. So when we get there, if there's other questions I can address on this first part, I will. But Ricky, I'm going to give it to you.
All right, thanks, Paul. As Paul mentioned, my name is Ricky McLean. I am with Woodworks. I'm a structural engineer with Woodworks team, and we're going to be going over a new tool that we're really excited to be able to share with you. This is a joint effort from both the American Wood Council and Woodworks, and it's meant to simplify and to speed up all of the heights and areas calculations that Paul introduced us to, and simplifying those tables. So this is an app. You can use this either for Android or iOS operating systems, on your phone, on your tablet. It is a free download, so you should be able to find it whatever app store you're using just by searching heights and areas calculator, and you should see it come up like this, calculator for IBC. You should be able to download that for free. So this next section here, we're going to run through the operation, the functionality of the app, the heights and areas calculator in the app, how it works, what it can do, and how we can see it pretty quickly can simplify some of those equations for determining construction type. So diving into the specifics of how the app actually works, you can see right off the bat on the top, and you'll see a large number of these screenshots from the app. So that's just meant to help you get familiar with what it looks like. So on the right, in this red box, you see there's two analysis modes. There's the basic analysis mode and an advanced analysis mode. Before I dive into the difference between those, I also wanted to point out that throughout the app, you'll see a lot of these useful pop-up screens like you see on the left here. And those are generally found by, if you just tap or click on the question mark that you see next to each of these bars, that provides this pop-up, which does a great job of helping explain either what's the difference, say, between these two analysis modes, or why is it asking for a construction type, those types of things. So it's just more informational to help you streamline the operation of the app. So as far as these two analysis modes, the first is the basic analysis mode, and this is modeled after the resource that Paul just mentioned, code conforming wood design. So this is meant to apply to buildings that are just single occupancy, but you can use multi-story buildings up to 6 stories. And what this does is it assumes that each individual floor has the same area. So as you see in this image on the right here, this is running through an example where you're using the basic analysis mode. You're assuming that the entire building is Group B occupancy, and that each of the individual floors is 24,000 square feet, and that doesn't change throughout the height of the structure. So let's take a look at a few examples to help get ourselves familiar with the operation of the calculator. This is the same example that Paul went through using code conforming wood design a few minutes ago. Now we're going to rerun that same building using the heights and areas calculator app. So again, we're using this basic analysis mode. We are assuming the 2015 IBC. We've selected an NFPA 13 sprinkler system. One thing to point out here is that Paul did allude to a few minutes ago that there is an option for NFPA 13R sprinkler systems in some occupancies. Group B business occupancies, like we have for this example, is not one of those occupancies. So it hasn't even given us the opportunity to select that. However, if we were to, say, change the occupancy here from Group B to Group R2, for example, then it would show us 3 different options for sprinkler systems: none, 13, or 13R. But again, going back to our example, same exact example from previous, 1 story, 15 feet, Group B occupancy, 25,000 square feet. We enter that information into the app here. And by the way, in terms of how that works, basically in order to enter the information, like where you see this 15 feet is, you would simply tap the screen there. It would bring a pop-up that allows you to numerically enter values. After we enter all of that information, we select calculate down here at the bottom right. And that will bring up the options that you see on the right. And basically what the basic analysis mode is doing is listing viable construction types. So we haven't had to go into this example assuming or guessing at a certain construction type. We just enter in information about the building, and it will tell us what are some viable construction types. And it lists those top down on this list, as you'll see here, in terms of the least restrictive to the most restrictive. So for cost effectiveness, usually we'll want to be selecting whatever the highest construction type is there. So for this particular example, you can see type 5B construction. It's allowing 3 stories, and of course we're just 1, so we work there. It's allowing a 60-foot tall building. Again, ours was just 15 feet, so we're fine there. And it's allowing 38,250 square feet. Our building was only 25,000. So this number also matches the value that Paul pointed out in the code conforming wood design. So what this is showing us is that type 5B construction, as well as all those listed below it, would be viable construction types for this building, given the input and the criteria that we placed on it. The other thing I wanted to point out here is the frontage summary that you see on the left. If you recall, this particular building was situated on a lot such that two of the exterior walls of the building were right on the lot line, and then two of the walls were set back from the lot line. So that's showing up in this frontage summary, where we basically have 0 clearance on 2 of the walls, and then we have either a 40 or a 60-foot clearance on the other 2 walls. And so that's calculating a frontage increase factor of 0.25. Another nice thing with the output and the information that's within the app itself is these pop-up menus that provide supplemental information about a given construction type. So in this particular example, we saw that 5B construction was listed as the top viable construction type, but there's this little box that we see off to the left here with a 2 in it. So if you select or click on that box, it will bring up this information text, where basically what this is telling us is that this particular building is not over limit in terms of the allowable floor area because it's sprinklered. In other words, if this building weren't sprinklered, type 5B construction would not work because it would be over the code's allowable floor area. So as you go down, you can see there's different pop-up boxes we can select. Again, these are really useful just for us as the designers to know, that either something is or isn't working and why. The other really useful thing here too is that if you want to kind of get behind the veil or behind the screen in terms of how is it actually coming up with this 38,250 square foot allowable floor limit, you click on that or tap on that, and it brings up this text box. It's showing the base 9,000 square foot allowable floor area value, the 0.25 frontage increase that we've calculated, the 3 times sprinkler sprinkler area increase, and then adding all of those up, that's how we end up with the 38,250. So it's providing those calculations. You can also, as you see here at the bottom, you can copy all of this text, and then you could then paste that into an email or a Word document. We'll talk a little bit later too about other methods of outputting this information in terms of sharing it with a design team or placing it on construction drawings. So let's run the same exact example, but instead we're going to have no sprinkler system here. Everything else is the same about the building size and the occupancy, but I wanted to run this with no sprinkler system so that we could illustrate what happens when a certain construction type isn't working. So now this should look quite a bit different. On the left here, you see we've got some text in red, we've got some boxes in red. Easy way to remember this is red means stop. So if you see something in red, that means that it's listed as a viable construction type. So there's a possibility, say, of getting type 5B construction to work. However, we need to change some things in order to do so because something is in red. So for example, if we select this 3 red box that you see over to the left here, that brings up this issue. And so this issue is telling us that as is, this building is over the allowable square footage limit. We're only allowed 11,250. Our building is 25,000 square feet. So what are some options? Well, we could do what it says below in the warning section here. It says that this building would not be over the square footage limit if we had NFPA 13 sprinkler systems. So that's one option. We could just add those sprinklers back in, and like we saw in the previous example, we would work at that point. Or if for some reason we don't want to sprinkler the building, what we could do here is just move down this list until we get a line that essentially has no red in it. So you can see type 4 construction would work there, or even type 3A construction. Also, I wanted to point out that you'll see some of these aren't necessarily showing warnings, they're just more informational. So for example, let's say we did select type 3A construction. So this is showing that 3A construction is working as is without sprinkler systems. However, there's something that we should know, and that is that in certain Group B occupancies, namely ambulatory care facilities, we are required to have sprinklers just based on that type of occupancy. So as long as this Group B building is not an ambulatory care facility, then we could run it as is, type 3A construction, unsprinklered. So it's important to know some of those footnotes from the code, and the app has done a really good job of incorporating those footnotes for information for your use. All right, let's run still a basic analysis mode example, but this time we're going to look at a multi-story building. So remember, again, the basic analysis approach here is assuming single occupancy throughout and that each individual floor is the same square footage. So in our case, we're going to use a building that's 4 stories tall, 44 feet, apartments, so our Group R2 occupancy. Each floor is 24,000 square feet, and this building has an NFPA 13 sprinkler system and is being designed under the 2012 IBC. So we enter that information into the calculator app, select calculate, and this time you can see what it's listed for the first viable construction type is 5A construction. So it's not listing type 5B construction. Essentially what that means is that given this building size and height, there's really nothing that we can do in terms of, adding sprinklers, adding frontage to get a 5B building to work, because it's not even listed as a viable construction type. So in this case, we would select 5A construction and go on our way. Now you'll notice that there is nothing in red here. However, there is still that box off to the left with 3. If we select that, again, this is more just information. It's not saying that something isn't working, but it's telling us that it is working because of some of the factors we have. In this case in particular, because the building is sprinklered, it's working in terms of the number of stories as well as the square footage. In other words, if the building wasn't sprinklered, we would be over the limit in terms of number of stories and square footage. And then similar to like we saw the sprinkler requirements for Group B occupancies, we have the same thing here for Group R. The code tells us that any new Group R fire area is required to have sprinkler systems. There are some options there, whether it's NFPA 13 or NFPA 13R. So this is a reiteration of the section from Chapter 9 of IBC that discusses that. So that's the basic analysis mode. Now we'll switch and take a look at the advanced analysis mode. And the main difference here is that I guess the 2 main differences. Number 1, we can now start analyzing buildings that are mixed use. So whether it's different occupancies on the same floor or one occupancy on one floor and a different occupancy on the next, this advanced analysis mode allows us to do that. It also allows us to analyze buildings that have different total square footages from one floor to the next. The other thing we're doing with this analysis mode is that now we're having to go into it with either a guess or an assumption of what construction type we're using. So like you can see here for this particular example, we're going to see if 3B construction works. Now the nice part is that when the output comes to you, it's not siloed just into 3B. It might tell you, hey, maybe 5A construction is also a viable option here. Maybe check that out. So it does provide other potential alternatives if something else may be a more cost-effective solution. So let's take a look at a multi-story mixed-use building example using this advanced analysis mode from the heights and areas calculator. Before we jump into the actual functionality of the app here, I did want to point out some of the code language behind how we analyze mixed-use buildings, and in particular, separated occupancy mixed-use buildings. Paul did mention that when we look at mixed-use buildings, we're basically having to make a decision of analyzing those as non-separated occupancies or separated occupancies. The advanced analysis mode of the app does assume that we're using a separated occupancy approach. So basically what we do for separated occupancies is that we look at the actual area of each individual occupancy and divide it by its allowable area. So we end up with a ratio. For each individual floor, we add up all of those ratios. So for example, looking at the elevation view of this building, let's say we're looking at level 1 and we have 2 different occupancies there. Maybe occupancy 1 has a total area of 10,000 square feet and the code allows us 20,000 square feet for that particular occupancy. So we would take the ratio, 10,000 divided by 20,000, we get 0.5. Then let's say our occupancy 2 has a total area of 5,000 square feet and the code allows us 15,000 square feet. We take the ratio there, 5,000 over 15,000, that gives us 0.33. We add those up, we get 0.83. As long as we're less than 1.0 at each individual floor level, that's the first check that we need to do. So if this level 1 had 5 different occupancies, we would have to look at each of those 5 occupancies, take the ratio for each and add all 5 of those together, and that sum could not exceed 1.0. The other check that we have to do in multi-story buildings is also look at the sum of all of the ratios for the total building. If it's a 2-story building, all of those, the sum of all of those ratios can't exceed 2.0. And if it's a 3 or more story building, the sum of all of those ratios can't exceed 3. So that, again, if we're a 3 or 4 or 5 or 6-story building, the sum of all of those ratios for the whole building can't exceed 3.0, and at no individual floor level can the sum of the ratios exceed 1.0. I know that may sound a little confusing, but hopefully the examples will help clarify that. So this is our example. Let's look at a 4-story mixed-use building. We have 4 different occupancies. Each floor is 40,000 square feet, so we end up with 120,000 square feet total. We have occupancy 1 is some apartments. So you can see we have some apartments on each of the 4 levels. We have some retail space on the 1st floor. We have some restaurant space on the 2nd and 3rd floors. And then we have some office space on the 3rd and 4th floors. We're going to assume that this building is sprinklered throughout with an NFPA 13 sprinkler system. And first, we're going to run the analysis assuming that we don't have any type of frontage increase. Whether that's true or not, let's just say for simplicity of design, we're not going to take that into account. We will come back later and recheck this example utilizing a frontage increase. So this is the app input once we start getting into the details of this advanced analysis mode. So this does look a little bit different. You can see on the right here, because now rather than just putting in a single line for the occupancy and the square footage and assuming that applies to all floors, now we're doing this on a floor by floor basis. So you can see here for floor 1, we've input a group R2 occupancy at 21,000 square feet and a group M occupancy at 9,000 square feet. We've done the same thing on level 2 for the applicable areas and occupancies there. Same thing down the line for levels 3 and 4. So we enter all of that information into the advanced analysis mode of the app. Again, we're not assuming any type of frontage increase yet. And we're going to run this as a type 5A construction and see if that works. So we hit the calculate button, and this is what we see. So we see some red. Red means stop. So something's not working here. So if we take a closer look at the numbers, what you see is that this value here at the upper right, the sum of the weighted ratios of the areas, what that's telling us is that we've added up all of those ratios for each individual floor, and they all add up to 3.26. And remember, for a 3 or more story building, the sum of all those ratios can't exceed 3.0. So even though each individual floor level, like you see here, is less than 1, right? We're in the range of 0.78 to 0.85. So each individual floor level is less than 1.0. That's the first check. We also have to add them all up for the total building, and that has to be less than 3. And in this case, it's not. So what this is telling us is that type 5A construction is inadequate. And if we hit that red box next to the 5A construction option, it's telling us why. And again, that's like we just reviewed. It's because of the sum of all of those ratios exceeds 3. So the nice thing, though, with the app is that in order to check something else, in this case, let's check a different construction type. All we have to do is go back to the main input screen and change the construction type. It's going to keep all of the input that we had previously for square footages, occupancies, etc. So in this case, we just toggle the construction type from 5A to 3B, rerun the analysis, and here you can see now we're down to 2.89 for the sum of all of those areas, which is less than 3. So this is telling us that type 3B construction is adequate for this particular building example. So with that, we'll go to our next poll question.
Yes, we will. Okay. In a multi-story mixed occupancy buildings, The sum of ratios of actual area to allowable area for any given floor can't exceed 1.0, 2.0, 3.0, or the number of stories. Okay, we've got about 3 more seconds. Okay, I'm going to close the poll and share the results. And the majority say 1.0, but we've got quite a few that think something else. So, Ricky, the actual answer is?
All right, so the actual answer is 1.0, which looks like most people got. The 3.0 may have thrown people because, again, the question is specific to any given floor. So each individual floor can't exceed 1.0, but you also have that second check if you're a 3 or more story building. All of those added together can't exceed 3. So there's the 2 separate checks you have to do on multi-story buildings. Let's take a look at that same building example. Remember, it didn't work as 5A, so we had to bump up to 3B. Well, what if we now start to account for frontage increases? Let's say this is a site plan view. These are our lot lines you see around the perimeter here. So we have some varying frontages, everything from as low as 10 feet on this north wall, up to 8 feet on the south wall, and then our east wall is a skewed line relative to the exterior wall line. The advanced analysis mode is nice in that you are allowed to do multiple frontage segments. This particular example is pretty straightforward in that it's a box. It's just 4-sided shape, but the advanced analysis mode does allow you to calculate frontage for, buildings that are L-shaped, H-shaped, all kinds of frontage distances and segments. So this is just telling us, what is a frontage segment. I think that will become clearer as we look at the actual input that we'll use here. So this again is in the advanced analysis mode. Now we're actually entering in our frontage segments. And again, a segment is just a length of exterior wall. So it's looking at first the north wall here, saying our starting clearance is 10 feet and our ending clearance is 10 feet. That's simply because the exterior wall is parallel with the lot line here. So we have a 10-foot clearance and then a length of wall of 200. Then we move to the west wall. Again, starting and ending clearance is 28 feet because that's parallel to the lot line. Same thing on the south. Now we're an 80-foot clearance. So the only unique one here is this eastern wall. So what we're doing here is we're saying our starting clearance is 55 feet and the ending clearance is 35 feet. By the way, it also wouldn't make a difference if we said our starting clearance was 35 feet and our ending clearance is 55 feet. You could do that either way. It doesn't make a difference. And then the length of the wall is 150 feet. So we enter in all of that information into the app. We run the calculate button. And this is trying again as type 5A construction. Remember, this didn't work before. I think it was about 3.26 for the sum of all of those area ratios. So now though, we've calculated this frontage increase, which in this case is about 0.455. And because of that, we've dropped this sum of the areas down to about 2.83. Of course, that's below 3.0. So that's another method of getting this building to work, right? We have the option of either not accounting for the frontage increase and using 3B construction, or we can account for the frontage increase and use 5A construction. And this is showing that output. And again, you could do this for any of the individual floor levels in terms of how is it calculating the allowable area using the frontage increase. And then same thing as before, you have this copy button at the bottom there for output. And speaking of output, there are several other methods to get a nice clean summary of what did the calculator analyze and what did or didn't work. So you see in the bottom left here of the screen, you always have this option of selecting this up pointing arrow. If you select that, it brings up several options like you see here. One of those would be print. So if you selected print, you can see basically it's just generating what looks like a Word document or a PDF, and it's a summary of what were the inputs that you put into this project, what construction type did you assume, and then what was the output. For each individual floor level, did it work or not? So you could do that, maybe print as a hard copy or print as a PDF. The other thing that you can do is if you select email here, it automatically generates a draft of an email where all of that same information is included. And of course, that's useful for sending around to the rest of the design team or to a building official that you're working with. So several useful ways of utilizing the output of all of the calculations that we just ran through, and getting those in a way that's useful so that others can see and validate that the calculations there. I also did want to mention too that our organization, Woodworks, we're a free resource to you. Feel free to utilize us. We have a great team of regional directors around the country. You can access your local one by using the URL at the bottom or contact our help desk. In particular, on this aspect of mixed-use occupancy buildings, this is an area that we get quite a few questions on, and in some cases we see there's some confusion. Many people assume that a mixed-use building has to be a separated occupancy building. For example, there's a project that we were assisting on recently, and it was quite a complex building. It was on a sloped site, so 5 stories on one end of the building, sloping site down to 6 stories on the other end. It was a hotel, but it had some mixed-use occupancies in it as well. And the design team approached us thinking that they would have to use either a type 2A or 1B construction. They just didn't think that they could get it to work in wood framing. Through some simplifications that we were able to help them use, things like the code's accessory occupancies provisions, incidental use provisions, small assembly spaces, as well as clarifying the separated versus non-separated occupancies approach, we were able to help them finally get to type 3A construction as working. They were able to use wood framing, and of course that proved to be a more cost-effective solution. Also on our website, we do have an Excel-based heights and areas calculator that you can use. It has some of the same functionality styles as the app that we just went over, so feel free to check that out on our website as a free resource as well. All right, for the next few minutes here, I wanted to focus on section 510 of IBC, and in particular, what the code calls the special provisions that are included there. All of the previous examples that we just looked at are assuming that the entire building is one construction type. So, and this is because of the requirement in section 602.1 of IBC, right? We have to select a construction type, and that's basically applied to the entire building. But what some of the special provisions in 510 contain are unique applications of combinations of occupancies or combinations of construction types, in essence, where we're stacking 2 different types of buildings on top of each other. So the most commonly applied special provision, I think, is contained in 510.2 of IBC, and that's what the code calls horizontal building separation. Most people refer to this as the podium provision or pedestal type of construction. It's like you see in the image here, where you're constructing 1 or more stories of non-combustible type 1A construction, and then on top of that, you're stacking what's often done as wood framing. There's some unique requirements there, like the horizontal system that's capping that podium, separating it from the building above has to be rated for 3 hours. The building below the podium has to be sprinklered. But the benefit that you get with this section of the code is, like you see here on the left, if we were to do what the code allows for a 5-story type 3 wood frame group R2 or any type of group R1 or 2 occupancy, we go 5 stories from grade plane. Now, if we take into account this special provision from 510.2, we can first build, say, 1 or 2 stories of podium from grade, and then on top of that, still stack our 5-story building. So in essence, we've gone from a 5-story building to 6 or 7-story building. Now, one of the caveats here is that the number of stories is measured from the top of the podium, but the overall building height in terms of feet is still measured from grade plane. So for the example on the left, a 5-story type 3A building, we would be allowed to go 85 feet from grade plane. Even though on the right, we've introduced this podium, we still have to measure that 85-foot limitation from grade plane. We can't measure that from the top of the podium. And this chart here is illustrating how this podium provision has evolved and changed throughout the past editions of the code to get to where we are now. really the two main changes have been the allowable types of occupancies in the podium, basically in the building below the podium. And then one of the bigger changes, it was introduced in the 2015 IBC, which lifted the restriction on the number of stories of the podium itself to 1. Previously, up to and including the 2012 IBC, that podium could only be 1 story above grade plane. Now in the 2015 code, there is no limit on the number of podium stories. So you could potentially have a 2, 3, 4-story podium. However, keep in mind that the overall building height is still measured from grade plane. So there is a trade-off there. You know, you might have heard of people describe these types of buildings as 5/1, 5/2. You know, that's typically talking about 5 stories of wood frame construction over 1 or 2 stories of podium. I did also want to point out the fact that I think people default sometimes to when they're using something like a parking garage underneath apartments, or something like retail, something with larger spans, they usually associate with other types of materials like steel or concrete. In many cases, they'll default to using that podium provision. However, you don't necessarily have to go there. There are some other options, which we'll illustrate next, that may allow a more cost-effective solution. One of those options is 510.4 of IBC, and this is a special provision unique to just parking that's underneath just Group R occupancies. So what the code says here is if we have just a single story from grade plane parking garage, and that's either type 1 or 4 construction, that depends on whether it's open or enclosed, and we just have Group R occupancies above, we can measure the number of stories for those Group R occupancies from the top of that parking garage level. The benefit here and the difference that this one has compared to the podium provision is that we aren't required to go full type 1A construction for that parking level, and we're not required the 3-hour separation that the podium provision has. Here we're just using, it's usually either a 1 or a 2-hour separation, depending on which construction type we've used, as well as if the building is sprinklered or not. 510.7 is similar to 510.4. Really the two main differences is that here it opens up the possibility for occupancies of the building above the parking, and then it also allows now type 2 construction to be introduced for that parking level. So just another option that does allow mixing of construction types within one building. And to hopefully tie all of that together, this is just an example 5-story building where we have the first floor is parking, and then we have 4 stories of residential above. Just a high-level view, what are 3 options that we could look at as potentially using for this building? Well, we could go 4 stories of type 5A construction over a 1-story type 1A podium using 510.2, or we could look at using 510.4 and still go 4 stories of type 5A, but now rather than going a full 1A podium with a 3-hour horizontal cap, we would be able to reduce some of those requirements in that podium level. The third option that we could look at doing is just going the entire building, say, as type 3 construction, 5 stories of type 3. The code does allow that if our parking level is enclosed. So that would be another option. And this post on our website, you can see the URL at the bottom there, discusses some of the unique code provisions specific to mixing parking occupancies with other type of occupancies in wood frame structures. And we have another poll question.
Okay, under section 510.2 of the 2015 IBC, how many stories can a building be below a podium be? 1, 2, 3, or no limit is given. I'm going to give you 5 more seconds. Okay. The majority of people, 64%, say no limit is given, and everybody else is across the board. Ricky?
All right, very good. The majority have it correct. Again, under the 2015 IBC, there is no limit on the number of stories for the podium level. So that could be 2, 3, 4. There's no limit given. Real briefly then, just to wrap up before we leave some time for Q&A, we wanted to at least provide a few resources available to you on the topic of construction fire safety. And the first is to point out that chapters 33 of both the IBC and the IFC provide provisions relative to enforcement of applications specific to construction fire safety. To give you an idea of what some of those provisions are, it's looking at things like hot work, placement of fire extinguishers, fire watch provisions are a big item to keep in mind there. And then the other resource we wanted to point out was the Construction Fire Safety Coalition. This is a coalition that is supported by the American Wood Council. This is a great website as a resource, constructionfiresafety.org. I highly recommend you check it out for resources, manuals, short videos. So really great resource. We recommend you check that out as well. So I believe we have some time for Q&A.
And this is Michelle that will be asking the questions. So first we had this was a really good engaging presentation, and we have some questions that came in for Paul and Ricky. So we'll start off with Paul. Starting on slide 22, if you could just clarify or provide some more in-depth information regarding the tables and sprinklers, non-sprinklers, and the footnotes.
Sure, Michelle. First of all, keep in mind that these tables are organized by sprinklered and non-sprinklered. It's easy to get in the wrong table. As you look across the table, you'll see, like for instance, 5B is listed for 1, 2, and 3 stories. Check the footnote there for E. Down at the bottom, type 5B construction does not permit 3 stories. Pay attention to the footnotes. In order to make these tables simple, we had to put some things down there. And also, these footnotes will point out things that may not be obvious in Chapter 5. For instance, look at footnote D. Sprinklers must be provided for ambulatory care facilities in accordance with something in Chapter 9. If you're only working in Chapter 5 and you're using these tables, you could miss something in Chapter 9. We've tried to catch those things in the footnotes, so pay attention when you look at these tables. They're quick to use, but be sure and pay attention to the footnotes.
Great. And another question came in regarding the weighted averages on slide 13, related to the WL. There you go.
Oh, that's the old slide, isn't it? We got the old slide up. Okay. We corrected this afternoon, but if you look at that top equation, it's wrong. It's missing some plus signs. So be careful. If you got the PDF from the morning, we've corrected it. It doesn't look like this anymore. Sorry for the mistake. it was my mistake in a hurry. That equation up there needs to reflect equation 5.4 in the code book, which actually adds L sub 1 times W sub 1 plus L sub 2 times W plus 2. So just be careful if you have an old PDF. And of course, always use the equations in the code book anyway, but thank you.
Right. Good clarification. Thanks, Paul. I have one last question for you regarding incidental use and using this, the calculator. How would you treat that?
It doesn't really address incidental use. You got to go into section 509. The calculator used to be in the code that incidental uses were part of the accessory occupancy provisions, which would allow you to treat them as, in certain circumstances, as non-separated mixed uses. That changed several editions ago in the code. So you have to, an incidental use is usually a smaller area of increased hazard, and it's required to be either protected with sprinklered or separated by fire resistance rated construction. They're listed in table 509. You got to go there and check that individually. So go use a calculator, but you do have to go to 509 to check about incidental uses.
Okay, thank you. And then some questions for Ricky. One has to do with the actual calculator and the occupancy per floor. How many different occupancies are you allowed per floor in the calculator?
This obviously would apply to the advanced analysis mode, as the basic analysis mode is assuming, single occupancy throughout. To answer that question, honestly, I'm not sure. I haven't tried to input more than 5 or 6, I believe.
Mm-hmm.
I don't know if there is a limit. We do have Ben on, who developed the software. I don't know if he has any input on that or not. He is saying now that there is no limit, so no limit's the answer. Yep.
All right, awesome. The other question is, how do you use the calculator when you're dealing with a podium type building?
Great question. Yeah, so typically what would be handled there is, because from a square footage and number of stories perspective, the building above the podium is considered separate from the building below the podium. Basically, what I would recommend there is that you run an analysis in the Heights and Areas Calculator app, just looking at the building from the podium up and not including the podium itself. Then the one supplemental check that you would have to do is that, does the overall height of the building, is it less than the allowable building height in terms of feet from grade plane? Because remember, from podium buildings, you do have to measure from grade plane, not from the top of the podium. So the calculator will assume that your building is sitting on the ground, whereas in fact it's sitting up on a podium. So that's the one additional check you would need to do.
Great. And have you come across where a design team has come to you and they're doing actually a type 3 building on top of a podium, but really they could get away with a type 5, and the calculator could help realize this?
Yeah, absolutely. I think that's very common. 4/1 type buildings, I think, are very common, but you're absolutely correct that a 5-story type 3 building could be a very viable alternative. So if someone were to use the calculator and just say, I have this 5-story building, can I make it work without a podium? The calculator could definitely determine that.
Okay, one more question regarding slide 52. And the question had to do with, the calculator showed 120,000 square feet. I think it's on the next, maybe it's the next few slides, but this is the start of the example. And someone was questioning, why didn't it show 160,000 square feet?
Oh, I may have misspoken, so that it was 40,000 square feet per floor. It is
Right,
30,000 square feet.
Yeah, I think that's what it was.
You can see if you add up the square footages for each, they all add up to 30,000. So I apologize if I misspoke there, but it is 30,000 per floor and 120 total. Yep.
Good, I'm glad we clarified that. Okay, any closing thoughts for you and Paul? Any comments that you'd like to do before we close it out? We're up at the top of the hour.
No, I don't have anything, Michelle.
No, I can't think of anything either. We're eager to get folks' feedback on utilizing tools like code-conforming wood design and the Heights and Areas app. So let us know what you think of them.
All right, great. And please feel free to respond to the survey. That feedback is how we improve on what we're doing here. And thank you everyone for joining us.